feet wet a little bit. What if I put okay, now if I put a battery facing up, it's telling me the current here changed to 1.07. What was it before? 0.75. And now let's check this voltage. How did that change? What was it before? 1.5 volts. Yeah, it completely changed. 2.14 volts. Okay, so how do we do this, guys? So now the voltage of the 10 is coming out, 2.14 volts. And then the current here is coming out 1.07 amps to the left. Of course, the orientation of the battery matters a lot. If I put the battery like this, switch the order, is the answer going to change? Oops. Oh yeah, way a lot, right? Now it's going to go 0.43 amps, right? Versus, and then the voltage is 0.86, right? So we could even write that down. So we could say if this is 9 volt, if 9 volt facing down, the voltage of the 10 turns into 0.86 and the current changes to 0.43. So it's like this. Has anyone done problems like this? You've probably done it, right, Daniel?
Yeah, pretty much.
Did they teach you other ways of doing this too?
I mean, besides KVL, KCL.
Oh yeah.
No, not really. I mean, it's pretty much like just using that.
Same.
Yeah. I mean, there's that way where we would use like Thevenin to say like, okay, well, let's replace one element with an open circuit and then get the voltage across those two terminals, and then we can get like the current and stuff like that way.
Okay, so I usually like to do something like this, like the current here, call this one I1. So I'm assuming the current is coming here, I1, and then over here, the current splits into, then call this, let's say, I2, and then this one would be I1 minus I2. Okay, so then you're saying some amount of current is coming here, and then here it's breaking up into some current, and then this is the remainder of that incoming current. The remainder of that incoming current comes here. Then and then that current splits up into some current, let's say I3, and then the remaining of that current, I1 minus I2 minus I3, comes down this way, right? So I'm not really looking at the direction of the battery necessarily when I'm doing this breaking up stuff. So I'm just saying some current comes, part of it breaks here, the rest, the remaining goes this way, then part of it breaks here, and then the remaining of that goes this way. And then they come here and everything joins up again. I2 and I3 join up with this guy. They join up, and then together you get I1 back again. Okay, then you do your loops. How many loops do you need here? You need 3 loops because you've got 3 unknowns, I1, I2, I3. So you can do this one loop, right? So you say, you go like this and you say, okay, I'm gaining 24 volts when I'm going up. So with battery, the rule is that if you're analyzing the current this way, when you go from the negative of the battery to the positive, you gain voltage, right? So then you gain 24. Then you go with the current across the resistor, you're losing voltage. Remember, this side of the resistor is at a higher voltage than this side. So current likes to flow from a higher voltage to lower, which means you're losing voltage as you go with the current. With the battery, you're gaining voltage because battery is like an elevator. It likes to raise the current to a higher voltage, you see. So you gain, then you lose. Then over here, you lose negative 20 I2. Then you lose another one. Then you come down, and then you're done with the loop. So then you end up having, let's see here, 24 is equal to 16 I1 plus 30 I2. So here's my first equation then. I'll do like that. I'm going to get 3 equations and 3 unknowns from this. For my second loop, I could go start here again, and then I could go like this, come down, and then go back, like that. So come down diagonally. So then you go 24, negative 16 I1. Then you go here. You don't lose any voltage because there's no resistor. Then you go down. So then what would be? You go down with the current, so you lose voltage, right? Positive, negative. So you're losing voltage. So negative 14 I3. And then for the battery, if the battery is facing up that way, then the plus is here, you see. So then you're losing 9 volts there. You're losing here, and plus you're losing across the battery. 9, and then that's it. And that's equal to 0. So then my second equation is what? 24 minus 9 is, what is that, 14? 4 and 5? Yeah, 9, 15, right? 16 I1 plus 0 I2, because I didn't have an I2, plus 14I3. So here's my third equation, second equation. So here, remember, I can put a 0I3 because I don't have an I3 in my first equation. So 24, 16, 30, 0. Okay, then what's left? Then my third equation. Well, I'm just going to stick to the same way. I'm going to go up, go across, and now go down and go across. You don't necessarily have to, because you could do this, this, this. You could do this, 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 this. You could do like that, like that, like that, you know, for your third loop. So you could do this way, this way, this way. You could do this way, this way, this way. Yeah. But I'm just going to stick to this like that. Then I can go down. So then I'm just going to do 24. And let's put it here. So positive 24. And then negative 16I1. Then nothing here. And then here's going to be negative 6I1 minus I2 minus I3. And then nothing, nothing, nothing. That's it. Okay, so this one had the most number of i's because of this guy, I1 minus I2 minus I3. So then 24 is equal to, okay, so this one goes to the right side, becomes positive. 16I1 plus 6I, well, let's write it this way first. I1 minus I2 minus I3. So you don't make a sign mistake. So this goes to the right side, becomes positive. So then 16I1 plus 6I1 is going to be what? 22I1. And then 6, so that's going to be negative 6I2, negative 6I3. Third equation. Okay, now here's the chance. I'm going to put it into your simultaneous equation solver. You go to applications. You go down to where it says simultaneous. You see that? New. Then you say 3 equations. Enter. And then 3 equations, 3 unknowns. You see? So then you put in the coefficients, A1, A2, A3, and then what they're equal to. It's very easy. So then you just have here, so 16, 30, 0, and then it's equal to 24. Enter. And then the next one is 16, 0, 14, and then it's equal to 15. Okay, and then the third equation, 22, negative 6, negative 6, negative 6, and it's equal to 24. Enter. Okay, then you press, you see here, the F5 button is solve. Okay, so I1 is equal to 1.0989 amps. I2 is equal to 0.2139 amps. I3 is equal to negative. So make a note of all the negatives. So there'll be 0.18, 449 amps. So So wherever you see a negative, that means that flips the direction of the current. You see, 1.098 and 0.2139, 0.18449. So what does that mean? If the I3, I believe, came up negative, right? Negative 0.18449. So that means that the current here is actually flowing up that way. You see, like that. So if I'm trying to just only check these two, then what would I do? The current here was moving to the left according to the app, according to the simulation, right? So then that would be 1.07 to the left, and then 2.14 was the voltage here. So how would I just check those? Well, then I would just calculate I1 minus I2 minus I3 to tell me what the current, that would tell me what the current of this is. You see, so then let's see, here's the moment of truth. I1 minus I2 minus I3. So 1.0989 minus 0.2139 minus, and of course I3 you have to do negative, right? Negative 0.18449. If it comes out negative, you're flipping it. Okay, here we go. And is that to the left also? Yeah, because I had, the way I had set it up was already to the left. So it's just to the left. So 1.06949. Look how close I am. 1.07 amps. Cool, cool, cool. Right? Okay, how do I check this one? B10, voltage of the 10. Then I just take my I2 and multiply it by 10, and that's it, right? Whatever I got for I2. So the voltage of the 10 would be just this one times 10. So that's 2.139 volts, right? Okay, 2.139. What was it? That? Yeah, that's pretty close. Yeah, 2.14. Yep, got it. 2.14, 2.139. Nice. Okay, let's take our break, and then we'll come